Drainage innovation at the Huronview Demonstration Farm. Environmental monitoring on the farm, combining the data collected. In the water quality video, it was mentioned that concentration data is difficult to compare when those values come from two different tiles or two streams that flow at different rates and therefore have different total volumes. It is very important to collect flow data and spend time managing it so that the water quality data can be paired with it for loading calculations. A pollutant load cannot be calculated without flow and nutrient concentrations. That's why both are important together and both are collected at Huronview. A pollutant load is calculated by taking the volume of water and multiplying that amount by the nutrient concentration reported by the lab. Pollutant loads can also take into consideration the size of an upstream area and be reported as kilograms per hectare, which is helpful when evaluating land management activities like agricultural best management practices. To determine the total pollutant load for a rain event so that events between tiles can be compared, it's best to have a concentration value for every flow record. At Huronview, flow is recorded every 5 minutes. It would be very difficult logistically and expensive to have a concentration value for every 5 minutes of flow. Our current approach is to match the concentration value reported by the lab with the flow value that corresponds to that time the sample was taken in the field. This leaves a table similar to the one on the screen where in between sampled concentrations there are flow values missing a corresponding concentration value. These gaps can be filled through an estimation process. In the previous slide, it was mentioned that gaps between sampled concentration values can be filled in using estimation techniques. There are different techniques for estimating the missing concentration values, and currently our approach is to use linear interpolation. Linear interpolation uses the first sample as a starting number and then gradually increases the concentration for every missing flow value. It stops when it reaches the next recorded sample concentration from the lab. With linear interpolation, the estimated values cannot be lower than the first recorded value from the lab or higher than the next sampled value. This process is repeated for each gap between the sampled values. Every recorded flow value is then multiplied by the corresponding sample concentration. All values for the entire rain event are added together and a total load can be reported. Loads are calculated on an event-by-event basis and our work has just started. An initial look shows that the water quality data from Huronview is similar to that of other research sites and published information. Water that leaves the surface as runoff has a smaller volume, but a larger load for total phosphorus and total suspended sediment. Water that leaves the field in tiles has a smaller load for total phosphorus, but a larger load for nitrogen, as well as a much larger volume.